So yeah, this is kind of about a slightly different approach we've taken with the UI on a project recently. Lots of TypeScript. TypeScript helped a lot with it, so I thought it'd make sense for this. We've called it data-driven UI. Actually, Ish pretty much explained our company, so I can skip through this really quickly. A lot of our work is around mortgages and fulfilling mortgages. We've been around for about 3.5 years. The majority of our stack is in JavaScript, Node, or TypeScript. To give a very brief kind of rundown of how the teams are structured within product, we kind of have lead acquisition on one side and fulfillment scalability on the other side. So acquisition are mainly concerned with kind of finding people who need mortgages and directing them to our site. Ideally, people with lots of money can easily get mortgages, but whatever. And scalability, who mainly work on making the actual getting of a mortgage as efficient as possible. The mortgage industry is pretty backwards by kind of technology standards, so that is a process in itself. I'm in the scalability team, so this is kind of a project we've been working on. A big thing we've been working on recently is having very auditable data. Reasons why: the level of accuracy we need to do a mortgage application is incredibly high. Getting that from customers can be quite difficult. There's kind of, they may give a right answer, but it isn't right enough for a particular lender. And they might kind of slightly contradict, say, their income with their savings or something like that. So we have to make sure that when we do make changes to data, it's very obvious why we had to make the change, and hopefully we can find out why customers keep getting it wrong and improve the user experience there. The other reason we need auditable data is that different lenders need different types of data. Sometimes they tell you, sometimes they don't, but we need to keep track of why we had to change data for a particular lender. And the third one I kind of mentioned before, the actual bit from deciding what mortgage product a customer should have to them actually having that mortgage product can be pretty manual. Most lenders don't have APIs. Their criteria are often kind of a combination of a PDF and some guy in some office. So you need to kind of make sure that if we can't change that part, we can at least keep track of everything that's going on. So hopefully we can improve it later. What we wanted to do was basically make a UI that gave some of the kind of mortgage experts in the company the ability to change every single bit of data there is on a customer, but make it very auditable, make sure all the changes are tracked. Cool thing about that, from our perspective, is a lot of the data is in a very similar format. Because we have control of the data, we can kind of get it in whatever format we want. It's kind of a back-end tool, so a lot of the kind of UX problems you get with users not understanding the context or not understanding exactly what's needed for a mortgage aren't applicable here. These are all experts who know exactly what's going on. And we quite like our React-y, TypeScript-y stacks. We probably weren't going to change that. So then we kind of had an idea of maybe we can put our data in a format where the UI doesn't really need to know the specifics of the data. All it needs to know is there is data. This is my amazing diagram. So imagine this is kind of what's coming out of the database or the domain in some way. We have some kind of conversion function in our backend server, and it comes up in a kind of more decorated metadata-y way. Basically config for how to display and edit and make changes to this piece of data. It's really easy to add stuff to if it's in this format, because you just have to add it to the array. And because we're using TypeScript on the server and the front end, you can actually share the type. So it's pretty easy to make sure that the server's happy with the type definition and the UI is. Are some basic constraints that come with this approach. You basically get no manual alterations to the UI. So if you want to add a bit of extra spacing around a particular question, particular input type, can't happen, because the UI doesn't really understand what the actual question input type really is. It just knows that it's something that is a date. That's not a major problem for us because all our users are kind of experts, so hopefully they should know what all this data means. The other thing you need to make sure you have is really well-defined relationships between all your data, because as soon as you maybe realize that something you thought was only one is actually potentially many, you have to completely rewrite your data. Like an example, maybe you just thought you needed a last name, but you actually needed a history of last names. Maybe you need to know that when they changed their last name, maybe they got married or something like that. If you did not take that into account, it's actually quite a big rewrite. So that sucks. But we hope we roughly know what we're doing with that sort of stuff. I mean, the third one I think is pretty important in general, is kind of abstract generic approaches to stuff like this can often just, all they really add is complexity. It's quite easy to accidentally recreate the DOM. If you start adding too much config, too many options. So you kind of have to keep your use cases pretty constrained. Luckily, we have very constrained use cases in this case. We know who's using all of this stuff. We know roughly what they'll need, what they won't need. So hopefully we won't hit that too hard. This isn't a totally new idea. I'm sure you know. Other languages have similar things, but I think probably the most popular one in the JavaScript world is ReactJS schema. Mozilla make it. It's really cool. It's well worth quickly checking out the site and playing around with it. That basically gives you everything you need to make any change to a form. We thought it was a bit overkill for what we were using, and we thought it'd be fun basically just to see. We tried an experiment to see how hard it was to make our own config-based kind of approach, and it was pretty easy, so we kept going with that. But if you have less idea of what your data is, less idea of what the use cases are, but you still kind of like the general idea, maybe check this out. Right, I'm going to attempt to show you a demo I've made this afternoon. This is an incredibly cut down version of what the page looks like. It's very, very simple. It's basically just rows. But you have the ability to edit and you have to give a reason why, and save. I'm just using like an in-memory kind of array on the server, so if I restart the server, all the stuff gets lost, but it does get persisted in some way. But you do get the idea, you do get the ability to, there is clearly a concept of types. Like dates have their own date input, they are displayed in their own way. Booleans get booleans, etc. So you can go a lot further with this, but this is kind of a very basic idea. I thought I'd jump into the TypeScript side of it. Let me just close that. So this is kind of the very basic type. Can you guys see that? Shall I zoom in a bit? I'll zoom in a bit. This is kind of the base set of data you need. So this kind of roughly represents that row you saw on the page. Input type's probably the most important part. That is about as meta as we get. A list of kind of roughly what type the input is. You can add to it, but these are kind of the ones you immediately get hit. Text, number, date, enum, which needs some kind of concept of what are the enums, and Boolean. Your base question has that. Has a key, which is essentially something that uniquely identifies it. Label, how it should look when it's displayed. Value, obvious. Read-only, whether it should be allowed to be edited. It's not actually in this demo, but there we go. Required, whether the value should be allowed to be not null. That's about the limit of our validation at this point. Then you basically make different types that extend that base type. So date, its value is string because I wanted this type to be serializable so the server and the front end could use it. We actually convert it, in the real version, we convert it to, I think, moment type, so we can play around with it a bit more. But string for date. Enum, like I said, you need this extra property here to kind of declare what the enums are. Number, the value is a number, kind of all makes sense. The kind of important thing there is you have to say what the input type value is, so TypeScript can start inferring. You do that for all of your different types. Then you make your actual question type, which everything uses, which is basically an OR of all those other types you declared. That allows TypeScript to, if you say the input type is a date, it knows the value should be a string. If you say it's a number, it knows the value should be a number, etc. That gets kind of added to our, kind of roughly represents the table type. So it just has a list of questions, and again, key to uniquely identify it, and some little metadata that kind of decorates it a bit. This is my very crappy server code that sort of shows what you can do with it. You can use that type on the server. So if I say, give this a value of 4, TypeScript complains because it knows that input type text should have a text type. And you can share that type, that question set type, with the UI. So this is the code for deciding how to display a particular value. So if for date, it formats it in a kind of date-like way. Enum, it checks the enum values and everything else. What's quite cool here is that TypeScript knows that because it's input type enum, there should be a property called enum values. You don't have to check for that, it's just there. Same thing here if I, this should be returning a string. If I try and return the question value, TypeScript is smart enough to know that that is wrong because that is a number. So this does actually pretty much constrain you to your definitions, which is quite cool. It's also really easy to now add extra data to this. If I say wanted to add phone number, obviously in real life this would be some value that's coming out of a database, but just to give an idea. Okay, input type. Text for phone number, I guess. It's really hard typing when you can't look at the actual screen. Required false, I guess. Value, that's what I'm missing out on, isn't it? If I now go back to our page and give it some time for the server to restart, the phone just got added there. I don't have to make any change to the actual UI, just the backend code. And all the editing and everything still works. So it's all kind of very generic. This isn't being recorded, is it? So yeah, adding is really easy, removing is very easy. It's actually pretty easy to extend this with other concepts like adding a whole new set of personal details or something like that. So it's working out okay for us. So learnings we've got so far with this approach, with pretty strict constraints, this seems to be working for us. You can skip the library if you don't want to add another huge library to your project. And TypeScript is very, very good at telling you what you can and can't do if you set it up right. That's kind of it, really. Next steps for us are trying to work out how we deal with complex validation, because we've just kind of skipped that for now. And it seems like this would work quite well with some kind of GraphQL approach to things, but we haven't really looked into that yet. Thanks.